Hi, this is the quiz key for today on planes and forces and all that stuff. So the first thing is that I had to take a picture of the key, so you're going to have to rotate the view. So what you do is you go to View, Rotate View clockwise, and then you'll see a lined up view. I think probably 30% will get you a nice big picture. First problem's pretty straightforward. These are the kind of problems you have to go through very fast because you're going to need the time to do more of the computational intense problems, and you also need the time to figure out what's wanted from you in some of the problems. So in this problem, you're given a vector A that your vector, your line is parallel to. And the first step is to take that point, and that's your R0. Then find the direction where the line is going. Well, if the line is parallel to this vector, it's going in that direction. So the direction vector is 6, 3, 2, and you write down the formula, which is R of t is R0 plus t times the direction vector, and that gives you what we call the vector equation. The separated components, x, y, and z, are what we call the parametric equations. And so x of t is 6t, y of t is 1 plus 3t, and z of t is 2 plus 2t. I asked you further two more things just to give me 2 points, just to see if you understand what this is giving you. And what you would do is you would just take two random values of t, not t equals 0, because t equals 0 will give you this point right here. So take t equals 1 and t equals 2, for example. Put them in for t into the vector form, and you will get 2 points out, just like we did when we plotted the unit circle that one day. So this is straightforward. I had to write the steps in. You don't. This should be bang, bang, and done. Second problem, you were given that a point on the plane, and you were given some information about your plane, that it's perpendicular to the line that's expressed by this parametric form. Now, here's my line, a pictorial explanation. The line is perpendicular to my plane, and that means that any direction vector that the line is going in is also perpendicular to my plane. Well, from the last problem, we know that the direction vector turns out to be the coefficients of the t. So if you just go back one page, see how 6, 3, 2 was my direction vector, and that 6, 3, and 2 ended up being the coefficients of my t. In the same way, I can go backwards and know that the direction here is going to be 1, 3, and negative 2. That's my direction vector. And this would be the direction vector pictorially. So it's also perpendicular to my plane. And I can use that since it's perpendicular to my plane. It is a normal vector. And therefore, I can use that as my n. Then I have to take that n and dot it with an arbitrary vector on the plane. The arbitrary vector on the plane is going to have tailed ahead from x, y, z to the given point. So if I formulate x minus p0, if that makes sense, x, y, z minus p0, this is what I get. I dot product these two things, and I set it equal to 0. That's because, by definition, the normal vector is perpendicular to any vector on the plane, so therefore their dot product should be 0. Once I compute that dot product, I have the equation of the plane. So I threw something messy in here because if you look at the past WPR, there's something messy. So I don't want you to trip up just because you see something messy. And so here, I'm given an angle and two vectors, and I'm supposed to find x such that the angle between the two vectors is 45. Seems obvious. I'm supposed to use the formula for angle between two vectors. If you go and look at the old WPR that's posted, several problems require you to use this formula. I would say that you don't have time to mess around on a formula sheet looking for this formula. You should know this one cold. I know it cold. So if I know something cold, that means I've used it. So this is something that's really important to memorize. Cosine of 45 degrees is equal to A dot B divided by magnitude of A times magnitude of B. A dot B turns out to be 2 plus x. Magnitude of A is 2 squared, which is 4, plus 1, which is 6. Then I take the square root. Magnitude of B is square root of 1 plus x squared. And it's not nice. So what you would do is you would cross multiply this baby, and then square both sides, and then you would use quadratic formula. I did just stick this into Mathematica. I do think that you should be able to solve this equation if you got into the Jedi math program, but just in case you don't, I have gaps in my own background too. So if you don't, then what you would do is square this side, the square roots would disappear. You would get a square on this side, square everything out, do the algebra correctly, you'll get a quadratic equation. From there, use the quadratic formula. I got 2 answers from this, and these are my 2 values of x's. A little messy. Work done by the force. Again, you had a WebAssign problem on it. It appeared on an old WPR. It's probably one that you want to know how to do. They give you work done by a force. If I remember correctly, you had a problem on your WebAssign with a sled. So this one could be formulated as a word problem. So be ready for those things. Force is given by this vector. It moves an object from point to point. So it's a vector. So the first step, I need a vector. So let's go to the formula. The formula for work is force times the vector that the object is moving on. The vector the object is moving on. So I don't have that vector, so I have to formulate that vector. So that's my first step. I go tail to head. 6 minus 0 is the first component. 12 minus 10 is the second. And 20 minus 8 is the third. Then I apply the work formula, which says work is F dot R. And you get exactly, I got 144 newtons. Right, I didn't have space to finish number 4 on the next page, so we're going to have to hop back and forth. But I went over this a little bit in class, but a little bit more slowly here, because this one is really important to understand. It appeared on a WebAssign problem. It appeared on the past WPR. Most likely it'll appear again. So a tugboat's being pulled in 2 different directions. You're given these 2 vectors. They're not force vectors. It's being pulled in those directions. And so what's happening here is that you have, this is pulling with a certain force and this is pulling with a certain force. You would like to know the resultant force. So where this tugboat, how hard is this tugboat being pulled? What's the force that's pulling that tugboat if you have these 2 different directions pulling it? Okay, well, unlike the problem you had on WebAssign and the problems that I saw in the book, I didn't give you the angles. You have to find the angles. I gave you the direction. Well, I just used a trick and said, okay, the angle theta 1 is made between A and the x-axis. And the x-axis, a vector on the x-axis is 1, 0. So from there, I could use the angle between 2 vectors. Notice I'm using that formula again to find theta 1. Someone in class mentioned that they found the angle between A and B, and I think that if you do that, you can find the angles theta 1 and theta 2 from there by using something with triangles. I've done something before where I was using, what do they call it, adjacent angles, and you can use that. For some reason, I had my angle between 2 vectors hat on throughout this whole quiz. So theta 2 you find the same way. In this case, if you look at theta 2, the angles are between 1, 0 and B. And so I do the same exact work and I get the 71.57 degrees. Next step is to compute f of x1 and f of x2. And there's a video on YouTube that I recommend that does this much better than I do. But when you pull, the first vector is pulling, F1, and the second vector is pulling, that's F2. They have both a force in the horizontal direction and the force in the vertical direction. So the first step is to compute the forces in the horizontal direction of force 1 and force 2. So I use the angle for force 1. I don't know f of x1. That's the force in the x direction. I know the resultant of that. That force is that's the actual pulling of the tugboat. That's 1450 newtons. They gave that to me. And I know this angle now, 63.43. Now I can use the triangle stuff that you learn in pre-calculus, maybe earlier. Cosine of theta is equal to adjacent over hypotenuse. And from that, I can get the force in the x direction, horizontal force. Similarly, I can do the same thing with the other triangle. It's the same exact issue. I don't have the adjacent. I have the hypotenuse. I have the angle, so I used cosine. And I get the force in the x direction, horizontal direction, of the second line that's pulling the tugboat. The total horizontal force is the sum of these two guys, which turns out to be 1,106.98 newtons. All right, the rest of my work is on the previous page. You do the same work for the horizontal forces. The only difference is in the horizontal forces, if I go back to these triangles I'm drawing, I'm looking for these guys, this drop down here. I'm looking for this. And so I would not use cosine, I would use sine. So sine of the angle times 1450 is equal to this guy. And sine of this angle is this guy. Now here's something to keep in mind. That's pulling this thing down the way I've drawn it, so this guy's negative. So Fy turns out to be this first force minus the second force, which turns out to be negative force. That's okay. That means it's being pulled in the downward direction. Think of that. The second angle was bigger than the first angle. It's pulling in that way. It's going to pull that tugboat in that direction. So that makes sense. So the magnitude is given by taking fx squared plus fy squared. So it turns out to be this, just a computation. The direction, I didn't finish computing this, but you can do that. You could just take the dot product of the vector fx, fy with 1, 0, the x-axis, right? That's in reference to the x-axis, and that will give you, solving for theta will give you the angle, which is the direction. All right, so this completes this quiz. I know it was hard, but I hope that this helps going through it earlier a couple times so that we are ready for this thing.